Okay, this is the ds-incubator, also again in the series about exploring data with the tidyverse, and today is a special day. It's the last meetup of the series and the last meetup of year 2021. So next year, which is gonna be pretty soon, we're gonna be talking about something else which we haven't yet decided. So maybe the first week I won't be asking for insights on what's the next meetup about. Maybe we'll take a break because I would love everyone to be involved in the poll. So maybe the second week we'll kick off with the next series. So today we're going to be covering patterns and models, and the objectives are three. First, we want to explore the relationship between two variables. Then we are going to be extracting a pattern between that comes from that relationship, and finally we are going to explore the relationship again once we have extracted the pattern already and see what remains. So that's the objective. Those are the objectives of today. And before we kind of start exploring some code, let's have a quick look at some general ideas about patterns and models. So patterns reveal covariation. So if variation is something that adds uncertainty, then patterns and are something that reduce that uncertainty. So models are just a tool for extracting patterns out of data, and we're gonna be using that as a way to see what remains after we extract that pattern.
Mauro?
Yes.
Are you intending to share your screen with us? Because you aren't at the moment.
Thank you. Yes. Let me share my screen. Thank you. And maybe Jackson, can you kick me out at 20 past as usual?
Happily.
Thank you. Because we have to go on with our end of the year celebrations. And where were we? So if you spot a pattern in the data, then some useful questions to ask are the ones following here, which come from the book R for Data Science. I'm borrowing them from there. And we're going to be using all of them except the last one. So some questions that you can ask to help explore data once you see a pattern are the following questions. So how would you describe that relationship that is implied by the pattern? Also, if you may ask yourself if that pattern could arise just from a coincidence, from a random effect, or not. Then you may ask how strong is that relationship, and what other variables may be affecting that relationship. And finally, and one that I don't think we're going to be kind of touching on this today, is that if the relationship changes if you look at subgroups of the data, because sometimes one group of your data follows one trend and another group of data follows a different trend. We are not going to be talking about that today, but it's kind of useful to have that as a cognitive tool to improve, to refine the questions that you ask yourself when you explore your data. As usual, we're going to be using the tidyverse and a new package that we haven't been using so far, which is Model R, which is not part of the tidyverse, but it was developed by the same team. So these days, there is a ton of tools for modeling in R, and Model R is one that is pretty old and very basic. So this meetup is mostly useful, I hope, for the concepts that we're going to be only kind of scratching today. But if you are really interested in modeling, this is certainly not enough. You need to kind of start exploring other tools. Actually, there is another Tidy Something team in our studio, which is the Tidy Models team. So anything by that team might be closer to what you want if what you want is to do hardcore modeling in R. So Model R is just a very simple tool. So let's start by playing a little bit with code. So we're going to attach the tidyverse as we usually do, which comes with dplyr and ggplot2 among other packages, but those two are the ones that we're going to be using today, plus Model R, which does not come with the tidyverse by default, so we have to attach it independently. So the first thing we're gonna do is a little bit of a warm up. We're gonna use a very simple data set that is called faithful, That comes from the datasets package in base R. And if I glimpse that, I'm gonna make this a little bigger, hopefully for more comfort to your eyes. It is a very small data set that has only 2 columns, eruptions and waiting. Eruptions is actually the time, the duration of an eruption of a volcano, and waiting is the waiting time between 2 eruptions. So those are just numeric variables. So for example, if we want to explore the covariation between those 2 variables, because those 2 variables are numeric, we now know that we could explore them with a scatter plot, which in ggplot2 you can do with a geometric representation called points. So the geom point is the function that we want. So actually I'm going to use autocomplete to make sure that I'm not misspelling the word point. As usual, we're going to be using ggplot2. Remember, we can omit the first argument called data. It's so common that we already know that's the first thing that goes there after ggplot2, after the call to ggplot. And also in the call to AES, we always do X and Y. So X is going to be eruptions, and our Y variable, our dependent variable, is going to be waiting. So if we plot this little scatter plot, this is what we get. So let's go back a little bit to the top of this document to think about this plot in terms of those questions that we were prompted to ask ourselves as a way to explore, to help ourselves to explore data. So one is, how can we describe the relationship that is implied by the pattern? So first of all, what is the pattern? So the pattern that we can see here is that, as the length of the duration of the eruptions increases to the right, we also see that the waiting time increases. So what we see here is that longer waiting times are related to longer eruptions. And that is apart from this other pattern that we can see here as 2 groups, but this grouping, this clustering pattern, is one that we are not going to explore in this warm-up. For now, let's focus on this linear trend that we can somehow see in these points, going from the bottom left of our plot to the top right of our plot, and it's a very strong relationship. So when we ask ourselves about how strong the relationship is, then in this particular case, it looks like a pretty strong relationship. And thus, if we ask ourselves if the pattern could be due to just chance, very likely, I would say no, because the relationship seems pretty strong. That is only qualitative, and we could use modeling to understand how to measure actually that strength of that pattern. But for now, all we want to do is to warm up. So we're going to extract that pattern and see what remains. So that is the warm up. So the way, what I wanted to complete this plot with is with that description of a description of the relationship that we see. So in this case, what we see here is that longer wait times are associated with longer eruptions, which it could be any other relationship. There could be no relationship, or maybe longer waiting times could be related to shorter eruptions, but this is not the case. So this is a useful exercise to try to describe what relationship we see in words. So now if I complete that plot, we can see this little title that describes what we're seeing here. So now it is time to try extract that pattern. And because the relationship that we see here is linear, or it looks like a linear relationship, we're going to just try with a very simple linear model, LM. So that's the function from base R that does linear modeling. And here we're going to write first the Y variable, so in this case, waiting. So this function takes first a formula, then a bunch of other arguments, and finally data. The only 2 arguments that we need are the formula and the data. The others are optional. So the data we know is faithful, and we are going to be creating a model to try explain waiting times in relation to eruption duration. So here is our model. If I print that to the console, what I see is just the summary of the model in a way. But we're going to be using model R now, as you can see here, to take the residuals of that model and add them to the data. So we're going to be using that package. If we just run this couple of lines, all we are doing is adding a new column. This dataset was a dataset with only 2 columns, waiting and eruptions. And now we have another column that is called receipt, which is the one that we just created. So let me go back to the top. Here we saw eruptions and waiting were the ones that came with the dataset, and we have just added receipt. We did that by calling this function here. So now we are gonna inject that to, actually, I don't think this call here is achieving anything. I don't know what's doing here. I'm gonna remove it. So right now, once we have that data set, what we're gonna do is we're gonna plot the relationship, but now between eruptions, and no longer we're gonna do it with waiting, we're gonna do it with residuals, because what we want to see is what remains after we have extracted the pattern that we saw. So we're gonna plot eruptions versus residuals with a scatter plot. So let's do just that. So now what we can see is that we still see those 2 clusters that were a pattern that we decided not to analyze for now. The pattern that we did extract was that linear relationship of increasing eruption times with waiting times. And that pattern is gone. You can see now that there is no longer a line going from the top, from the bottom left to the top right. So that is what we have achieved with the model. We extracted that pattern that was so obvious here. So that idea is very powerful, and we are now going to use it again in a different data set to do something that is quite a bit more challenging. So you may have remembered from previous meetups, if you were here, a plot that looked like this. It comes, so the data that we're exploring here is the diamonds data set, and there was something quite odd when we tried to plot the price as a function of the different qualities of the diamonds. So the variable is called cut. That's the name of the variable in the diamonds data set. It encodes for quality of diamonds. And if we just plot, quality versus price, we see something pretty odd, which is that these fair diamonds, which are the ones of worst quality, on average they seem more expensive than diamonds of better quality. So that is very unexpected. And at the time we saw this graph first, we did not have this tool, or we didn't even spend time trying to think much why that could be the case. But the answer to why that odd relationship appears here is actually quite simple. The issue at the time was hard to understand because there is not just a relationship between these 2 variables. That relationship is complicated by relationship with other variables. So in this particular case, the relationship between quality and price is complicated because the weight and the quality of the diamonds is also, of course, related. So you would expect that weight and quality are, let me show you this plot here. So here what we are plotting is cut, which is the quality, and karat, which is the weight. So this relationship maybe is not so, you wouldn't think of this relationship as so obvious, but the way I think about it, so basically what we are noticing here is that there are more, basically that the bigger diamonds tend to be of worse quality. And I'm just thinking that maybe it's because otherwise, like if a diamond is too big and too great of a quality, it could be also like very expensive. Maybe it is very hard to come around diamonds that are of very good quality and big. or maybe because people don't buy things that are so expensive. I don't know, there may be a few reasons why this relationship exists. But the fact is that this relationship does exist, so the size of the diamond also plays a role. When thinking in terms of what's the relationship between the quality and the price, you also need to account for the size, right? So this plot is saying that there is a relationship between the quality and the size of the diamonds that will complicate any understanding that you try to get from analyzing the quality with price, for example. So this is one part of the equation, and then the other challenge is this other one. So the other relationship, the one that is kind of more obvious, is that the size, of course, is also related with the price. So and then analyzing the relationship between, so in summary, analyzing the relationship between quality and price is complicated because there is a relationship not only between those two variables, there is another one there that is also adding to the pattern. So what we want to do now is basically to try extract the relationship that we have between price and weight, so that we analyze the price and the quality once we have somehow standardized for the weight. So we have to make the price relative to the same weight, right? So that's what we're gonna do with the tool that we have just learned, with the model. And because these relationships look linear, then we're gonna be using a simple linear regression. So once we do that, once we extract the pattern between the quality and price, we are gonna be between the weight and between the weight or size and the price, then we're going to reanalyze the relationship that we explored before. So let's create a model. The model is going to be, in this case, we're using the log of price, but I think we do price, we would see it would kind of work anyway. I'm just following log because I see that in the book. So, just to stick to the book. But we're going to be then basically the y variable here is price, and the x variable in this model is carat, right? So the size of the diamond. So we have just created that model as we did before. Printing a model to the console is not very interesting. It's kind of boring. What we're going to do is what we did before with the previous model. So we add the residuals, and now we are going to be turning the residuals, because we use log here to transform the variables x and y, then the residuals, we're going to do the exponential of it, so kind of to revert the effect of the transformation. That way we'll have things in the same unit. So once we have added the residuals to our data set, we can use them to plot the quality, not now versus the price, but versus the residuals, which could be, in this particular case, would be the price after we have removed the effect of the size, right? So that is the beauty of that model. So this is the resulting plot. If we plot quality now versus this residual price, we see what we would have expected before, which is the idea that once we make the price relative to the size, then better diamonds are more expensive. So the price increases with the quality of the diamond. So that's it. And there's a final insight. So Jackson, I know that you are very keen to kick me out. I think I'm gonna take only a few seconds to just spell these insights out once again. So once again, patterns are things that reveal variation. If variation adds uncertainty, then covariation, you can think of it as something that reduces it. Because of the following, because if two variables do covary, then you can use one to better make predictions of the second one. And in a particular case, when the relationship is causal, which is just a special case, then you can not only predict the second one, you can actually control it, right? So if you know that doing X causes Y, then you can stop doing X, and then you don't get Y, right? So you can control it. And finally, models are a tool for extracting patterns out of the data, which is what we have done here to better clarify our thinking when we wanted to think in terms of just two variables, so we remove the effect of a third one. Okay, that covers the meetup of the day. Let's see if we have questions, comments, maybe comments for people who have been doing some modeling before. That's not me. I did very limited and a long time ago, so I don't have much to add. So people, I'm hearing you. Any experience in the group about modeling, or any questions in terms of what we've seen today or the entire series, because we are wrapping up right now? No, I think, Jackson, I think at some point you were very into machine learning, right? Weren't you?
Yeah, I got into like it was um, when I was doing astrophysics stuff. We got into like Bayesian inference and Bayesian modeling and stuff like that. I'm just hesitant to talk about it because it's been so long. I'm really forgetting the details of it.
Yeah, same for me. I did some analysis during my PhD, but it's so long ago. Monica.
Yeah, same for me. I actually did a lot of modeling in the past, but it's been a while. And I think with this, like with your examples, it's really cool because the models are very simple, so you can visualize all these effects. And I really enjoy this kind of models because like you also can see that it makes sense. And with a lot of models that I worked with, they were like risk management, I don't know, very abstract, some kind of Fourier transforms that I couldn't really see that my models make any sense. So yeah, I think it's really cool when you have a relationship that's so simple that you can actually visualize it, or at least parts of it.
Yeah, I agree. Okay, cool. I also enjoy preparing this material precisely because I am interested in modeling as a tool for the power that it comes from understanding the world with the help of models. But the field has developed so much lately, so much beyond what I've studied when I studied it, that is even overwhelming. So it kind of was good to go back to the basics. Okay, this is what I'm trying to do. Here is the pattern. Here is what the residuals look like once I remove it. Because I think that these days, if I try to learn anything about modeling, if I have the feeling that I should spend at least a week just to scratch the surface of what's the new trend in modeling. But maybe I'm wrong, and there's a lot of useful things we could do. And indeed, I do know that Max Kuhn, the main developer, the lead of the Tidy Models team, he's very into simple models. I mean, I think he always advocates for, there is all these cool, super sophisticated, tools that you can use, but then, if you can explain, your data with this, with an LM, much better, right? So before you go to something more complicated, try use the tools that are kind of easier to kind of wrap your head around. Okay, any departing thoughts? Otherwise, I'll call it a session, and I call it a year for the ds-incubator. Okay, sounds like this is it. Thank you very much for sticking with us this year. And I hope you the best for the end of year celebrations. See you next time.
Okay.
Ciao, ciao.
Bye.